Okay, good morning class. Today we'll start with geometric optics. Feel ko alam nyo naman yung idea naman kayo kung ano yung gagawin natin for today. Okay, last time, napos lang natin yung mga equations na kailangan natin for interaction of light with materials. Ngayon, tingnan natin kung paano natin siya aralin when producing images. Okay? So, meron tayong object and meron tayong image. Okay? So, when an object, ito yung mga object natin na nagbibigay ng light. It can be a luminous object, parang sun, ganyan, light bulbs. And pwede rin naman na nire-reflect niya lang yung ilaw tulad ng mga normal objects natin in real life. Diba? Tayo by ourselves, we do reflect light. Kaya tayo nakikita ng ibang tao. If we don't reflect light, hindi tayo makikita ng ibang tao. Okay? So, meron tayong tinatawag na point object. So, literal point. Titignan natin yung a single light ray coming out from a point source or a point object. And then an extended object, which is yung mas realistic na object natin. Ang extended object ay yung mga object na with dimension. Okay. Can be something like this. Can be an arrow. Tapos, titignan natin yung multiple light rays coming from this kind of object. Okay. So, hindi natin kailangan i-consider lahat ng light rays coming from an extended object. Kailangan lang natin yung sum of the light rays, at least 2, no, para mabuo yung image natin. Okay, 2 light rays coming from the object. And then, meron tayong, for the image naman, meron tayong tinatawag na virtual image and meron din tayong real image. Okay? So, yung virtual image siya kapag yung light rays natin, nandoon siya sa side nung imaged form. Okay? Kasi some interface, kuwari, let's say, we have a mirror. Siyempre, di ba, intuition natin, alam naman natin yung makikita natin sa mirror. Pag may object na ganito sa kaliwa, tapos ito may mirror ka, ang makikita mo ay yung itsura mo. Di ba? Gulat ka, iba, hindi mo nakita itsura mo. Gawin natin realistic na. Let's copy this. Para legit na kamukha niya. Okay. Tapos, kung dapat pink. Mapansin nyo, syempre, yung light rays coming from the object will just be reflected back. Diba? So, yung mapansin nyo dito, yung image nasa kanan, pero yung light rays niya nasa kaliwa. So, ang tawag sa kanila ay virtual images. Ito ay virtual images. On some cases, nasa same side yung image tsaka yung light rays, yung outgoing light rays. Yan, tawag sa kanila real objects. Real image naman, sorry. Okay? So, meron tayo yung in this point, meron tayong tinatawag na incoming light and then outgoing light. Okay? Okay. Ito. So, meron tayong signed rules pero ihugutin din natin ito mamaya. just to ano lang, just to be familiar with lang tayo. Okay? So meron tayong tatlong distances na mahahalaga para sa pagtalakay natin sa geometric optics. So meron tayong object distance, image distance, and the radius of curvature. Okay. So yung object distance would be the distance of the object from the vertex of the interface. Okay, so object distance natin would be this part, S. Okay, tawagin natin siya S. And then the image distance would be the distance from the vertex to the image. Tapos yung radius of curvature, ito yung kuwari kapag meron tayong interface na spherical. Siyempre, di ba may center ito. Yung center siya na kuwari nandito. So that's the distance of the radius of curvature. Okay? Okay, and then there are some sign rules accompanied by these distances. So yung object distance, kapag yung distance na yun ay nasa same side ng incoming side, so for this case, S is on the same side as the incoming light, okay? So mangyayari sa kanya, positive. And then negative siya otherwise. Okay? For the image distance naman, kapag nasa same yung outgoing light or outgoing side is on the same side as the image distance, positive si image distance. Okay? Negative otherwise. Okay. Then yung radius of curvature, kapag yung outgoing light is on if the radius of curvature or yung center niya, yung center point niya, the same side ng outgoing light, then it would be positive, negative otherwise. Okay? Okay. Parang ano, no? Parang yung object distance laging positive. No, parang pag-isipin mo, dapat naman sir, di ba? Dapat incoming light manggagaling sa object. So, dapat nasa same side sila lagi. There are times na kinukuha mo yung image ng image. And yung unang image, wala sa kanya yung side ng light. So, pag ganun, negative yung object distance. May times na ganun. Okay. Okay, so not always na positive yan. And then meron tayong lateral magnification. I-define natin yung lateral magnification as y prime over y. So, ibig sabihin lang y prime ay ito yung image height over object height. Ano naman, obvious naman kung bakit ganito yung ng magnification. Siyempre, kapag y prime greater than y, then y prime over y greater than 1. Tama? Makes sense, di ba, na greater than 1. Mas malaki siya dun sa original. And then, for the case that y prime is less than y, which intuitively tells you that the image is smaller than the original. Okay. And sometimes, meron tayong tinatawag na inverted kapag y prime less than 0. Okay, nakabaliktad. Ibig sabihin, nakabaliktad yung image na nakatutok pababa. Tawag doon ay inverted. And then, on the usual case na positive yung y prime, tawag sa kanya erect. Okay? Okay. So, wala lang. Mga nilalatag lang muna natin yung mga, ano natin, mga things natin. Okay. Saka natin ngayon, titingnan yung reflection and refraction sa mga iba't ibang surfaces natin. Okay. Okay. So, meron tayong plane surface, spherical surface, and thin lenses. Okay. For the plane surface, meron tayong plane mirror. Natalakay na natin sa Snell's law yung ano, yung surface, tapos NA, NB. Okay, so natalakay na natin ito, madali lang. So dito. Meron kasing ganito. Ay, okay. Talakay na natin yung ganito. Para may light ka. Ay, then alam na natin to, di ba? Okay, walang bago dyan. Yung sa plane mirror nga lang, lahat nagre-reflect. So, paano ka gagawa ng image doon? Okay, so gawa tayo ng interface. Gamitin na natin tong drawing natin para hindi tayo mahirapan in life. Yeah. Evidently, when you have an object, so gawa tayo ng hatayong ano dito, arrow dito. May arrow tayo dyan para mas cute yung ano. Okay, so the incoming light is going down. Tapos, para mabuo mo yung image mo, ang usual na ginagawa natin ay ito-trace back mo yung ano, ito-trace back mo yung outgoing light. Okay, so let me do that. So, gagawin mo, di ba, meron kang incoming light, tapos meron kang outgoing light. Yung outgoing light, trace back mo like this. Show mo nyo na straight line siya, no? Medyo mayroon mag-drawing eh. Okay, and then from that, and then let's build another ray of light. So, yung sa ilalim, gawa tayo ng light ray na pa ganun. Is shape na lang natin. Para cute. Ganun siya. Okay. Then, drawing lang natin dito sa kabila yung image. Okay. Ayan. So, usually ginagawa, iti-trace back mo yung i-trace back mo yung outgoing light para mabuo mo yung image mo. Okay, so mamaya mas maganda yung natin, mas formal yung pagdodrawing natin kahit dito sa plane mirror. Yung mahalaga lang is that para makuha mo yung makuha mo yung tawag dito, image distance is that in-negative mo lang yung object distance. Okay. Hindi ko mas intuitive the other way around the equation. Okay. Di ba mas intuitive to? Kasi alam mo pag plane mirror na yung object mo ay usually positive siya. Tapos yung image distance mo is usually negative. Kaya mas madali intindihin to. Pero nilipat mo lang naman yung negative sign. Okay, kasi yung image distance, bakit siya negative? Kapag positive si S. So, pansinin nyo dito, yung image na dun sa side na walang outgoing light. Sinabi natin na kapag yung image distance positive, dapat na same side C, outgoing light, tsaka C image. Okay? So, that's for the plane mirror. Dito naman sa spherical surface, marami tayong cases. Okay, so una ay meron tayong spherical concave mirror. Okay, ibig sabihin, pag may concave tsaka convex, ang usual thing na iniisip ko is that kapag concave, dapat may space ka below your arch. Okay. So, yung material mo nandito sa taas. Okay, so is side view lang natin. So the spherical concave mirror looks like this. Ayan. Tapos, meron tayong tinatawag na mga bagay-bagay. So, the optical axis is this line. Okay. And then, meron tayong points na tinatawag na center of curvature, vertex, tapos focus. Okay? Center of curvature, vertex, tsaka focus, or focal length. Okay? Or focal point. Kung point yung tinitingnan mo. Okay, ito yung mga kailangan natin mamaya. So, yung vertex, medyo naman siya, madali siyang intindihin. Siya intersection ng optical axis mo, no, tsaka yung curved interface mo. Tapos, the center of curvature would be the center of the spherical interface. Okay, so yung focus naman, di natin siya alam, pero somehow it tells us that whenever parallel rays come into contact sa lenses mo, ay sa mirrors mo, or sa spherical interface mo, lagi siya magpupunta sa focus. Okay? Ayan yung definition ng sa focus. Alright. Okay. So, let's try to understand yung equations guiding our concave mirror. Okay, let's say we have a point object P. Tapos, syempre, tatama siya, magbibigay siya ng light. Bigay siya ng light. Going to point B. And then, from that, syempre, di ba, whenever you have light in contact with something, lagi mo titignan yung normal line. Okay? So, yung normal line in this case would be the radius. radius. Tama, di ba? Kasi for any spherical or circular, lahat ng perpendicular line ay radius. Okay, so by geometry, ayun siya. And then, syempre, by law of reflection, yung angle theta must be the same for both incoming and outgoing. Okay, so itong theta, itong dalawa dito, would be same for incoming and then outgoing with respect to that normal line. Okay? Okay. Okay. Now, ayan, nabuo mo na yung dito. Nabuo mo na yung dito. Incoming and outgoing. Sorry, I'm lagging. And then, marami pa tayong angles na pwedeng makuha. Okay, so meron tayong alpha here. Okay, alpha, which is yung angle between the optical axis and the incoming light. And then phi would be the angle of yung radius na ginamit natin dito with respect to the optical axis again. And then beta would be the angle between the outgoing and the optical axis. Okay, so simplihan lang natin ang buhay natin. Okay, intindihin natin yung mga triangles, no? So, di ba yung internal angles ng triangle should be equal to 180? Okay? So, alam natin from this point. Tawagin ko to na yung mga kabilang angles ng mga alpha, phi, and beta to be alpha prime, phi prime, and beta prime. Okay, ano ibig sabihin ko? Ito yung dito, alpha prime, which is simply 180 minus alpha lang naman. Mahaba lang siya, tamad lang ako. And then, ito ay phi prime, ito ay beta prime. Okay? Okay. So, let me just erase them para hindi magulo. Okay, so, yung unang triangle would be this part. So, yung alpha, theta, and phi prime. Okay, so we have alpha plus theta plus phi prime. And this must be equal to 180. And then another one would be phi prime plus phi plus theta plus beta prime. So we have phi plus theta plus beta prime equals 180. And then what else can I do? Okay. Ito na, alam na natin ito. Mag-solve na natin. Pwede natin subtract to para mawala yung mga theta. When we subtract this, we have alpha minus phi plus phi prime plus beta prime. Minus beta prime. Minus beta prime equals 0. And then we know that phi prime is just 180 minus phi. And then beta prime is the same, 180 minus beta. So we just plug in those things. So this is plus 180 minus phi minus 180 minus beta, so plus beta equals 0. Okay? And then 180 cancels out. We have alpha plus beta must be equal to V. Okay? You can, syempre naman maraming ways to understand this kind of relationship here. Pero ayan, ginamit ko lang yung madadaling idea, yung geometry. Diba triangles, 180. From that, nakuha natin itong relationship nito. Okay? Okay. So, what else? What else? Okay. From here, meron siyang tinawag na tawag dito, H, which is just yung height ng height ng B, yung point B with respect to the optical axis. And then delta, which is yung distance nung distance from the vertex nung projection nung height ng B. Okay? Okay. And then, alam natin na yung S is this whole thing. So, therefore, we can build relationships, tangent relationships for alpha, beta, and phi. Okay? So, tangent alpha is actually opposite over adjacent, diba? So, opposite, which is yung H natin, over adjacent, which is just, dapat yung triangle lang kukunin natin, di ba? So, that part is S minus delta. S minus delta. Then tangent beta is the same, almost the same thing. S prime minus delta nga lang. Then tangent phi is H over R minus delta. Tama. Okay? Okay. So now, may mahalaga tayong approximation na kailangan gamitin. So yung ang gagamitin natin would be small angle approximation. Ibig sabihin lang yung alpha natin is small. Naman tayo sa okay. Is small. So ang mangyayari is that tangent theta is just theta. Okay. Okay. Tangent theta is theta. So with this, implication din ng angle na alpha small is that pag maliit yung alpha, lalapit yung B towards the optical axis. And then yung delta mo would become very, very small then. Okay? Angle mo will become very, very small. Yung delta mo will become very, very small. So these three relations here would become alpha H over S, beta H over S prime, then phi would become H over R. Okay, so plugging these values into our equation, we have H over S plus H over S prime then must be equal to 2H over R. We cancel those H, we have this equation, a familiar one. Okay, so we have this equation. Ta-da! Okay. Now we can write this as we can write this in terms of the focus. Basta alam natin definition ng focus. Okay, the definition of focus is that sabi nga natin kapag yung parallel rays or yung mga light rays that are parallel with the optical axis, they must converge to the focus. Okay? So how do we do that? From here, lagay natin yung object natin at infinity. So, magiging ganito siya, 1 over F, and then, 1. So this becomes 0, and we are left with 1 over S prime equal to 2 over R. And sabi nga natin, nagko-converge yung light rays papunta sa focus. So, ibig sabihin, yung 1 over S prime natin is just the focal length, which is F. Therefore, F is just R over 2. Okay? So, you have that. You have this. Pag pinlagin mo na siya doon, magiging ganito na lang. Kasi F over 2 to, kakancel yung joke, yung R over 2 ay F. Okay, so magiging 1 over F na lang. Okay. Okay, so what if nilagay mo yung object mo sa focal point mo? Medyo sira ulo ko lang. Lagay natin 1 over S plus 1 over F and then 2 over R. Okay. You know already that these two are equal. So this must be 0. This must be 0. So yung object mo mapupunta sa infinity. Okay. Ay, yung image mo pala mapupunta sa infinity. So balik ka rin. So ibig sabihin, pag tumayo ka sa focus, hindi mo makikita yung wala kang makikitang image. Kapag nasa concave mirror ka, mawawala ka. Okay, and then for extended objects, let's try to draw things. Okay. Alam ko na yung mali ko sa drawing ko kanina, kaya hindi natin mabuo yung image. Try natin ito. So, yung gagawin mo palang light rays na isa mo pang kailangan would be yes. Green gawin natin. Okay. So, syempre, by kung normal yung normal yung incidence niya, babalik tatalbog lang yung light, di ba? So, that being said, i-retrace back mo ulit yung retrace back mo yung outgoing light. So, the intersection between those two traced back na light would be where your image is formed. Okay? Yan. Medyo sabog lang. Okay, going back. Let's draw things. Okay, so suppose meron tayong concave mirror. Tapos we have an optical axis here. Okay. And then we have an extended object. Okay, and then some points of interest would be center of Curvature. Focus is half of that distance from the center. So, half ng radius. So, around there. Hindi ko sure, no? Parang ano lang, approximation lang. Okay, and then... Okay. Ang maganda dito is that usually you can use this always, no? Yung parallel ray. Sabi natin, pupunta siya sa focus. Okay? So you have that. And another one would be coming from your law of reflection. So, mula doon sa ulo ulit, punta ka dito sa vertex. Alam mong normal line agad yung alam mo normal line agad yung vertex. So, gagamitin mo lang yung law of reflection. And somewhat around here, yung mabubuo natin. Tama ba? Therefore, the image is formed. Image is formed around here. Okay. Okay. Napansin mo inverted yung inverted yung object natin, yung image natin. So, kung ano natin 'yan, napansin mo that you have two triangles. Tingnan natin na maigi. Meron kang triangle number 1 which is related to your object here. So, yung triangle na yan. And then we have another triangle sa baba which is related to your image. Okay? Napansin nyo, same yung angle nila. Same yung angle nila on one vertex, on one, tama ba? Ito formal term. Anyway, basta alam nyo naman na itong angle dito ay same lang sa angle nandito by law of reflection. So these two triangles are equivalent. Okay? So therefore, we have this relation for the magnification. Okay? Okay. So bakit may negative sign? Kasi yung y prime mo is negative, di ba? Tapos y is positive. Tapos both your s prime and s is positive kasi mapansin mo dito, yung s mo, positive siya kasi same side nung incoming light, yung object mo. Okay? And then the image, nasa same side din nung outgoing light. So therefore, they are both positive, S and S prime. So we need to add a negative sign here to cancel out yung coming from the y prime. Okay. So nandito lang ulit yung sign rules para maalala natin yung pinag-agagawa natin. Okay. Sa spherical convex mirror naman, so spherical convex naman ay ganito itsura niya. Okay. So, nandito yung material o sa right side. Okay. Kung mapapansin mo, if you try to bounce a light here, intuitively, you know this already, that tatalbog siya. Somewhere. Medyo pangit yung position ng ano natin. Ulitin natin. So, medyo OA yan natin. Dito sa taas. Okay. Yan, ganyan siya. Kasi ang normal line is, ayun. Ang normal line mo is around here. Okay. So, by law of reflection, ganyan siya. Okay, and then similar lang din sa baba, pababa lang naman. Okay. So, pansin mo, lahat ng outgoing light rays, they are not converging unlike this sa concave mirror mo. So, lahat dito nagko-converge yung outgoing light to a single point, kaya may nabubuo kang image. Okay, and then on this part, yung mga light rays mo, they are bounced off the mirror. So, paano yun? So, let's draw the optical axis here. Para lang di tayo magulo. Okay, and then if we have an extended object, there, tapos may incoming light ray again papunta sa vertex kasi siya yung madaling i-graph. By law of reflection lang. Okay, now we trace back those outgoing light. So here, pababa. And then from here, papunta dito. So now you form an object, an image here. Ayan siya. So ganun na-form yung na-form yung image. Okay. So mapansin mo dito S prime is negative kasi hindi sila nasa same side, no, yung outgoing light tsaka yung image mo. Okay? Another one is that yung outgoing light is not on the same side dun sa radius of curvature. So, negative yung radius of curvature nito. Okay? Negative yung R niya. Okay, so let's have an example. Si Santa daw, dahil nag-aakyat bahay na naman siya, tinignan niya yung damit niya kung may dumi. So, sa isang Christmas ball, which is around a meter away, so 0.75 meters. Yung diameter daw ng ornament, yung ball is 7.2 centimeters. Tapos, yung height niya is around 1.6 meters. Okay, so ang tanong ay where and how tall is the image of Santa formed by the ornament? Is it erect or inverted? Actually, pwede ka na hindi mag-drawing dito. You just have to plug in things. Okay? So, ang kailangan natin is where yung image. Okay? So, alam mo na agad na image yung hinahanap mo. Image distance yung hinahanap mo. So, you isolate that sa equations mo. Okay? So, 1 over S prime must be equal to 1 over F minus 1 over S. Okay? So, yung object distance is 75 meters or 75 centimeters away. Tapos, yung F mo would be diameter Kunin mo yung radius, 3.6. Tapos kalahati ng radius is your focus, so that's 1.8. Now, it's negative dahil sabi ko nga, yung radius of curvature, negative for a convex mirror. So you add that negative sign. And once you do this calculation, you can see that sanity check lang din na negative dapat si image distance. Okay? Okay, so yung 1.76, nandun siya sa loob nung ano. Sa loob siya nung Christmas ball mo. Okay? And then the magnification is still the same. Ganun pa rin yung gagamitin mo. Okay? So y prime over y must be equal to negative s prime over s. So s prime and s alam natin yan. Sila y hindi pa natin alam. So therefore, plugging in things. So 7 yung s prime 1.76 negative. Tapos 75 centimeters. You have this kind of magnification, 0.002. 0.02. Okay, so mapansin niyo yung sarili niya mas maliit. More than usual. Okay, and then from there, makukuha mo na yung y prime. Kasi alam natin yung y. Alam natin na in-approximate natin yung height niya as 1.6 meters. Therefore, makukuha mo yung y prime. Okay. So, 3.8 centimeters siya doon sa Christmas ball. Okay? Ayan. We'll have more examples next week. Okay, graphical methods. Meron tayong tinatawag na principal rays. So, meron tayong parallel ray, focal ray, central ray, and vertex ray. Kanina, ginagamit natin yung vertex ray tsaka yung parallel ray. Okay? Kasi alam natin madali sila. Kasi alam na from the definition of the focus, doon natin nakakuha yung parallel ray. Okay. So, drawing natin lahat yung mga bagay na yun. So, here, medyo rough lang yung drawing natin. No? Gandahan nyo na lang sa notes nyo kung nag-notes kayo. Let's have an object. Okay. So, number 1 would be parallel ray. Alam na natin to. So, lagyan pala muna natin ng labels. Labels. So, around here yung center, around here yung focus, vertex. Parallel ray is parallel to the optical axis. So, there. And then going down to the focus. Going down to the focus like that. So that's your parallel ray. Okay? Focal ray is anything that's going, when you have a light that is going through the focus. So let's do that. Focus siya. Ayan. You can see. Ayan. Ayan ko. Focus naman dinaanan niya. Mangyayari is that yung outgoing light would become, kabaliktaran lang, parallel naman siya ngayon. Okay? And then, what else? Next natin would be central ray. central ray. So, ang gagawin naman natin is that the light must pass through the center. Yes, kaya ko to. One center. Yan. Okay. So, obviously, dumaan siya sa radius and yung tatamaan niya is a normal line to the curve. So, therefore, babalik lang siya. Babalik lang siya. Okay. And then lastly, alam na natin yung isa pa, which is yung vertex ray. Dadaan ka lang naman sa vertex. And that makes your optical axis the normal line. So, law of reflection lang gagamitin mo to guide your outgoing light ray. Okay. So, by ang galing, no? Hindi ko minamind yung kung saan sila dumadaan, pero nabuo, nakikita mo kung saan sila nagko-converge. Nakita mo kung saan sila nag-converge. Doon siya na-converge. Amazing. Okay, so this is still viable sa convex mirrors mo. Pansin mo that with this kind of drawing, yung focus mo is actually here, vertex is here, center is around here. Okay? So, ganun pa rin. Kapag nag-drawing ka ng incoming lights such that it's like going through the center. So, from here, trace back mo lang. So, parang around here, no? Tatama siya sa center. So, ganun pa rin. Magiging central ray pa rin siya. Parallel ray. Focal ray is around here. Focal ray is around. Okay, tinatrace back ko lang. There. Vertex, same pa rin. So, ito, yung focal ray magiging sample na natin. Magiging ganito siya. So, magiging parallel ray na siya. Yung outgoing. So, ganun pa rin. It works for every mirror. Okay. Okay. Tapos, pag zinero mo yung F, no? So, di ba F is distance from the vertex to this point. Pag zinero mo siya, lumalapit siya dito, ibig sabihin nagiging straight yung mirror mo. Nagiging plane mirror ka. So, babalik kayo sa equation natin kanina, which is this. Diba? 1 over S plus 1 over S prime is equal to 0. Joke. Pag zinero mo yung F, magiging infinity, no? Hindi pala pwede. Ang baliktad pala nasa isip ko. Pag nilagay mo yung F sa infinity pala. Sorry. Medyo tanga lang yung Medyo tanga lang yung ipapasok mo sa loob sa okay, sorry. So, kapag ganito yung curve mo, ibig sabihin around here yung center mo. So, pag nilakihan mo pa, lumalayo siya. And then, kapag ginawa mo straight, no, mapupunta at infinity yung F mo or yung R mo. So, this becomes 0. And that tells us that S is equal to negative S prime. Okay. Another one is that, paano pag violate natin yung small angle approximation? Paano pag violate natin si alpha? ginawa natin siya malaki. So, ano yung mga cases na malaki yung alpha, no? So, pag si P, si point object mo, lumapit siya around here. Ang nangyayari is that, drawing nga natin. Ang nangyayari is that you have this, and then your object is somewhat here. O rough drawing na lang. So, gawa ka ng ano, no? May focus pa rin naman siya, which is around here. And it's the same thing. Gawa ka ng light rays that looks like going from the focus. So, magiging parallel ray siya ulit. Napansin mo, di ba? Mas malayo yung image niya. So, magulo yung image niya pagdating sa dulo. Kaya yung equations mo would become quote-unquote unstable. Hindi mo makukuha ng accurately yung S prime, yung image mo. But, this is usable naman kahit gawin mo kahit gamitin mo siya sa ganun. Okay? Next would be a refracting surface. So, nagre-refract naman yung surface natin. Kanina, puro reflecting lang, no? What if ngayon nagre-refract naman? Siyempre, nagre-reflect din to, so may image by reflection din. Meron din, pero ngayon, titingnan lang natin yung image by refraction. Okay? I have notes here. Okay. So una, tignan natin yung relationship ng A, ng alpha, and then, pwede pala. Okay, sige. Ano ba ito? Okay, himayin muna natin yung light rays. No? So, may incoming ka, may point object ka at P. And then, we suppose we have two light rays coming in. So, yung tatama sa vertex, syempre, diretso lang siya kasi normal yung incidence niya. So, ibig sabihin, di sa kanya gagana yung mga refracting equations mo. And then, kapag at an angle alpha ka na, pag tama mo dito, titingnan mo yung normal line, and then your angle from that, which is theta A. And then, for this assumption na yung incoming index ng refraction of the incoming side is less than the index of refraction doon sa outgoing side, so NA less than NB, your light rays go towards the normal, okay? Towards the radius, okay? So from here, pansinin mo, may outgoing light is towards the normal line, which is the radius. So theta B is less than theta A. Okay? And that this is your image point, P prime. Okay, and that yung angle nun is beta. And then, as usual, phi is from this. Okay. Optical axis to radius. Okay. Okay. Paano ba to? Nalagay sa notes ko eh. Okay, gawin muna natin yung mga um, equations for tangent. Tangent alpha must be equal to h over s plus delta. Tangent beta would become h over s prime minus delta. And then last one, tangent c. Pero I think hindi natin kailangan to. Wait lang. S r minus delta. Teka, let me visit the textbook. Okay. Okay, kailangan pala natin. Nice. Okay. Okay, going back. Okay, ano. Naalala ko na yan. Naalala ko pinagagawa ko yung live. So, ang mahalaga dito would be getting the equations that govern yung beta and yung mga thetas mo. Okay? From here, mapapansin mo that sige, i-continue ko lang tong ano. Continue natin yung light ray dito. Part na to. Yung sa outgoing, no? So that tells us that this is also theta b. Sige, pangit naman. Gawin natin yung ginagawa natin kanina, yung very simple way of doing it. So, si beta plus theta b plus this angle, which is phi prime, must be equal to 180. Gawa tayo mga triangle na. Next one would be finding theta A in terms of hirap mag-geometry, no? Pag pagod ka in life. Dahil mo kailangan tignan. Okay. Nice one. Nakita ko na siya. If I were to add theta A here, this would be this part here is alpha, since these two lines here are parallel. Okay, so nice. Theta A must be equal to phi plus alpha. Phi plus alpha. Phi plus alpha. Okay. And then from here, makukuha ko na si beta. So ito ay 180 minus phi. So plus theta B plus beta. Okay, nice. Ay, 180. And then 180 cancels out. We have theta B to be equal to phi minus beta. Okay? Okay. And then we have these equations. Tapos we have what else? We can relate theta A and theta B, tama? So NA sine theta B, theta A is equal to NB sine theta B. And then since we are using small angles here, sine theta is also equal to theta. Okay? So this becomes NA theta A and B theta B. And then plugging in things. So what's this? NA times phi plus NA alpha must be equal to NB phi minus NB beta. Okay? And then let's just rearrange this. So NA alpha plus NB beta. And then this must be equal to NB minus NA of times phi. And then, since small angles tayo, yung alpha magiging h over s prime, and then h over r. So therefore, we have NA h over s plus NB h over s prime must be equal to NB minus NA h over r. Okay? And h cancels out. We have this equation. Nice. Okay, ayan. And then for the magnification, in a similar way, kunin mo lang yung meron kang dalawang triangle, di ba? This one and this one. Tapos kunin mo yung relationship nung nung tangents. Tapos since meron kang mga sin theta, di ba? Sin theta A at sin theta B. Makukuha mo yung magnification, which is y prime over y, to be equal to this. Okay? Na huwag natin derive. Hindi naman kayo magde-derive sa for satisfaction ko lang yung pagde-derive. For some of you. Okay? So, applicable ba to sa iba't ibang NA and NB, no? Yes, nag-apply to. Pag binaliktad mo naman, mas kapal quote unquote, optically yung NA, yung sa kay NB. And okay lang din, mag-work tong equation na to. You just have to plug in things. Okay? Okay. And then, a nice thing about this is that kapag ginawa mong plane mirror yung, ginawa mong planar yung planar interface. So, mag-zero out yung mag-zero out yung right hand side kasi R goes to infinity. Zero out. So, we have this NA over S plus NB over S prime equal to 0. Okay, so ang ano nito ito yung mga magandang example. Kasi ito. If you look straight down into a swimming pool na nakasabi raw na 2 meters yung lalim, so gano'n siya kalalim pag sa paningin mo, di ba? So yung object mo dito would be, so drawing tayo ng pool. Okay. Alam mo na sabi nung mga attendant sa pool na 2 meters yan yung lalim. Okay, so yung object mo actually here is that yung bottom. This is your object nasa baba. Tapos, if it has a light ray going this way, okay? So, away from the normal yung itsura niya, di ba? Kasi, from large to small, from big to small index of refraction, mag-bend away from the normal. Okay? So, ayan. So, ayan yung itsura nung thinking process dito. So, yung object mo would be your S. So, that's 2 meters. And then, let's say NA, the water, is 1.33 and 1 for the air. So, saan lalabas yung image? No? Gano'n kalayo yung image? Okay. Okay. So, kapag ginrawing mo to, meron ka bang, pwede pa tayo maglagay ng isa pang ilaw. So, babalik lang din siya sa akin. And then, kapag niretrace back mo, so, kung saan nag-meet, parang doon yung lalim ng floor. Okay? So, ayan. 1.5 meters lang siya pag tinignan mo sa swimming pool. Okay? Kaya usually, nalulunod yung mga bata kasi na-debated sila sa dun sa lalim ng pool. Mukha lang siyang 1.5 meters. Pero 2 meters talaga siya. That's a lot, no? That's a lot. Half meter. Isang kamay din yun. Okay. Punta tayo ngayon sa thin lenses. So, thin lenses is that ito siya. Meron dalawang focal points which is of the same, usually the same focal lengths. Ayan. From the lens center siya, yung measurement. And yung positive siya kapag converging lens. So, ito yung converging lens. Convex lens ito. Okay, convex lens ito. Nakalito siya, no? Kasi yung convex dito sa mirror ay diverging yung light niya. So, medyo nakakalito siya. Pero, ayun nga, tinatawag naman siyang converging lens para mas madali yung intuition. Okay? So, yung first focal point, nanggagaling siya sa likod na side. Okay? So, likod na side, ito yung focal point niya. That's the first focal point. Then, yung nasa left, siya yung second focal point. Okay? Ayan. So, parallel rays papunta pa rin sa focal point. And galing yung mga focal ray, magiging parallel naman siya. Ayan. Pansinin nyo to, yung first focal point, sabi ko nga, galing sa likod. Okay. Quote-unquote likod. Nasa right side siya. So, ayun yung first focal point. This is the diverging lens naman. And then, yeah, ayan. Ayan siya. Okay, diverging lens naman ito. So, ganun pa rin. Parallel rays. Paglabas, magiging nakatutok, quote-unquote, nakatutok sa focus. So, ipag-retrace back mo siya, papunta sa focus yung mga light rays. Okay? Alright. Okay, so you have this. And then, we have here the lens maker equation na hindi na natin gagawin na pag-derive. No? Okay, so ang mahalaga dito is that meron kang focus, focal length. And then, index of refraction nung lens material. Tapos meron kang yung difference ng radius of curvature nung dalawang surfaces. Okay, so yung R1 would be pertaining to the right curvature, no? So itong part na to. Yung R2 yung nandito sa kaliwa. Medyo nakakalito siya in a sense. Okay, so this is the lens maker equation. Gamitin mo siya pag may lens. So yung kanina, ito yung gagamitin mo kapag in general na refractive surface. Okay. So yung thin lenses mo, special case siya ng refracting surface. Dalawang refracting surface lang yun. Okay, so kapag binilagyan pang boundary sa dito, so NA, NB, NA, yun yung mangyayari. Ganun yung derivation niya if you want to look at your book. But then again, this additional additional knowledge na lang yan kasi hindi naman kayo physics major again. Probably you won't use this in your life. Ay, the joke lang. Yung mga optics na topic, magagamit nyo in life. Okay. Minsan kasi nilalabas siya sa mga general knowledge exams and math, whatever. Okay? Okay, any questions? Hindi pa tapos yung chapter. Meron pang examples on the cameras, telescopes, correcting vision. I-discuss natin sila as examples next meeting. Okay, any question? Wala. Okay. So kung wala, dismiss na. Tapos may tanong sa akin si Allen sa Canvas. Mathematical lang ko, so kung sino gusto magstay, okay lang naman. Okay, go lang naman. Okay, so stop